All right, let's begin this session with homework exercise number 10 from section 11.3. Senate is contained of 54 Republicans, 45 Democrats, 1 independent. How many committees can be formed if we need 3 Republicans and 2 Democrats? Okay, so now we've got to keep the Republicans and Democrats separate. So we have to do the Republicans first and the Democrats. Now, we don't have any independents, so the 1 independent, we're not really going to work with that at all because we don't need any independents. We just got to get Republicans and Democrats, so we'll work with the number of Republicans, number of Democrats. Now, Republicans, you're selecting 3 on the committee. Order doesn't matter. Whether you're picked first, second, or third, you serve on the same committee. If order doesn't matter, it's a combination. The total number of Republicans is 54, and we're selecting 3. Democrats, same idea. 2 Democrats from 45. Order doesn't matter, so just the numbers are different. Total of 45, and we're selecting 2. Now, this is the 54C3 is a number of ways to get the Republicans. We'll do that on the calculator. 45C2 is a number of ways to get the Democrats. We'll do that to get the actual value, and then the answer will be this value, 54C3 times 45C2, because we got to get Republicans, then Democrats. So by the fundamental counting principle, or principle of counting, you've got to take the number of ways to get the Republicans, multiply by the number of ways to get the Democrats, to get the committees of 3 Republicans and 2 Democrats. So there's that extra step of doing each combination, but then you have to multiply to get your final answer. Okay, so for Republicans, that's 54C3, right? So we put in 54, we go to math, and then we hit the right arrow 3 times, and then we choose number 3. It's a combination, order doesn't matter, and we're selecting 3 Republicans from a total of 54, right? So the answer for that, well, the number is 24,804. Now we got to do it for the Democrats. 45 Democrats, math, go over to PRB, and again, it's a combination for the Democrats. Order doesn't matter. This time we're got 45, and we only selecting 2, so the number is 2, so that value is 990. So we're going to take 990 and times the number of ways for the Democrats times the number of ways for the Republicans, 24,804. The order doesn't matter as long as we multiply the 2 numbers together, and believe it or not, we get a lot of different ways, combinations. 24,555,960, because there's so many Republicans and Democrats, right? There's 54 and 45, so that's a lot. So that's why the number is so large. All right, very good. That solves problem number 10. Let's look at number 11. In a race with 5 automobiles are entered, there are no ties. In how many ways can the first 3 finishers come in? The way I interpret this problem is first, second, and third. You're looking at the order, right? So how many different ways, whether you come in first, second, or third, like if it was Tom, whatever, Jack, and Kevin, if you switched around the order and had Jack, Tom, Kevin, then it would be a different way of doing it, even though it's the same 3. So, but it's a different order. You count it differently. So order matters here. So it's a permutation. Okay. So be careful. So this order matters on this one's a permutation. We've got a total of 5, and we're selecting the top 3. So 5p3. The formula for permutation is 5 factorial, the number on the left, and then it's 5 minus 3 factorial. So it's 5 times 4 times 3 times 2 times 1 over this is 2 times 1. Cancel. 5 times 4 is 20 times 3 is 60. So again, you could have used your permutation key on the calculator, but it was small numbers, so it's pretty easy to do it by hand. Again, the answer is 60. Okay, so let's put that in to verify we're correct. There it is. And again, on the calculator, sorry, I forgot to clear the previous problem. It is 5 math, and then it's over to probability, 3 right arrows to highlight, probability. This is a order matters. It's a permutation, so it's number 2. 3 finishers, so we're selecting 3. And there it is, 5 NP3 is equal to 60, which is what we got when we did it by hand. Okay, a health inspector must visit 3 of 12 restaurants on Monday. In how many ways can she pick the restaurants? Now, be careful here. She's just picking like McDonald's, Burger King, Taco Bell, okay? She's picking them. If she switches around and does Burger King, then McDonald's, then Taco Bell, it's the same 3 restaurants. She's just picking them. It's not the different ways that she can visit them, right? The different orders of visiting, but she's just picking them. So interpreting it like that, the order does not matter, right? Because as long as you pick the same 3, you're just picking them, right? So picking them order does not matter, so it's a combination. And there's a total of what? 12, and she's picking 3. So the answer is 12C3, which is 12 factorial over 12 minus 3 factorial, which is 9 factorial times then the number on the right, 3 factorial. So you have to write them out, reduce when you can. Again, you could do 12 times 10, 12 times 10, forgot 11, huh? 12 times 11 times 10 times 9 factorial. 9 factorial, 3 factorials, 3 times 2 times 1, the 9 factorials cancel. So it's 12 times 11 times 10 divided by 3 times 2 times 1, and you'll get your correct answer. Fortunately, you can do it on the calculator with the combination. So we've got a total of 12, and we're doing a combination, so math. Highlight probability by going the right arrow 3 times. Combination is number 3, where she's picking 3 restaurants. So 12C3, and the total is 220. All right, very good. Number 13. Textbook search committee is consisting of 15 books for possible adoption. The committee has decided to select 8 of 15 for further consideration. How many ways can they do this? Again, the 8 selected are for further consideration. They all are going to be in the final running or whatever in the top 8. Doesn't matter whether it's picked first or second or third. It's going to be one of the final 8. So order does not matter. Order does not matter, right? So what? It's a combination. The total number is 15, and we're going to select 8. So again, if you've got to do it, if you don't have a key on your calculator, you got to do 15 factorial, and then 15 minus 8, 7 factorial times 8 factorial. Write them out and reduce. Hopefully you can do that. If you need help with that, just send me an email. But anyway, use your calculator. So we've got 15C8, so close the ink layer. 15 math, over the probability, right? Right arrow 3 times. Order didn't matter, it's a combination, and we're selecting 8 from a total of 15, so 15C8, that's what we need. And the calculator has a formula built in, tells us it's 6,435. All right, which is indeed the correct answer. How many different 2-letter passwords can be formed from the letters A, B, C, D, E, and F if no repetition is allowed? Now again, if I pick the letters A and B, that's one password, right? But then if I do B followed by A, that's a different password. Same 2 letters, but the order is different. And so in this case, a different password, it means order does matter because we get a different password when we switch the order. So order does matter. If order matters, it's a permutation, so capital P. From the letters A, B, C, D, E, F is a total of 6, and we're choosing 2 letters, so 6P2. So it's 6 factorial divided by 6 minus 2 is 4 factorial. So 6 times 5 times 4 factorial. The 4 factorials cancel. So 6 times 5 is 30. So the numbers were pretty small, so I just did it by hand. Obviously, you can use your calculator to do 6p2, and you'll get 30. All right, very good. And that is indeed the correct answer. Okay, we're going to stop this session at problem number 14. All right, this is your math teacher, Dr. Swears. If you need more help on any of these problems, send me an email through the inbox in the Canvas course through the FGCU portal. I hope you found this video helpful. Thank you for viewing it.